Hello, we're going to be looking at double replacement reactions this week, plus a little on combustion. Hopefully you guys have watched the videos of the reactions. Hope by the end of this short set of notes, we'll be able to identify features of a double replacement reaction, identify something called a driving force for a double replacement reaction, and explain what a hydrocarbon combustion reaction is. All right, so double replacement reactions. You guys watched a couple of videos on those. Essentially, they are ionic compounds that are dissolved in water. So you start with two different ionic compounds. Here are A, B, and C, D representing two different ionic compounds. And essentially, when you dissolve them in water, they split apart into their ions, and then they sort of trade places, if you will. So the positive ion, which is the first one in each ionic compound, they swap places. So positive ion A then combines with negative ion D, and positive ion C combines with negative ion B to form two new ionic compounds. Here's an example of one where you have a solution of an ionic compound, copper sulfate, and a solution of an ionic compound, sodium hydroxide, and you mix the two of them together. And you wind up with this insoluble substance at the bottom of your flask. The insoluble substance is referred to as a precipitate, and then what's in solution above that is sodium sulfate. All right, so why do double replacement reactions happen? And if you mix any two random ionic compounds together, will one occur? Not necessarily. In order for a double replacement reaction to happen, one of the products that forms by exchanging the cations has to fit one of three criteria. It has to be insoluble in water or form a precipitate. Those are the ones that you watched in the examples. They all formed an insoluble substance in the test tube. They can also sometimes form water. H2O sometimes gets formed, or they might form a gas, or they would form a substance like hydrogen carbonate, which immediately breaks down to form a gas. All of these substances are referred to as being a driving force for the reaction, because if you swap the ions and all you do is form an ionic compound that doesn't meet one of these criteria, nothing really is going on. So why do these products make the reaction happen? So all the initial reactants are ionic compounds in solution. So here is a beaker that contains sodium chloride. All the ions are split apart and you can see them in solution. The second beaker here is silver nitrate. All the ions are split apart. But when you mix them together, some of them don't stay in solution. When a silver and a chloride ion get together, they form an insoluble product that settles out of the solution on the bottom of the beaker. And so if the products remove a set of ions from the aqueous solution, that's a driving force. So those driving forces are, again, an insoluble product or a precipitate, water, or a gas. So if we look at these four equations, we can look at the products to figure out what's the driving force. So in the first equation here, I can see that I've got the state symbol solid for the silver chloride, so that's the driving force. In the second equation, I have the state symbol solid for this compound, calcium sulfate, so that's the driving force. In the third equation, one of my products is water, so that's the driving force. And in the fourth equation, I have hydrogen sulfide, which is a gas, and that's the driving force. All right, to switch gears, we're going to take a brief look at the components of a combustion reaction. I think the video pretty much covered most of what you need to know about combustion reactions, and we're only going to look at a subset of those, which are hydrocarbon combustion reactions, where you combine a hydrocarbon, which is essentially a substance consisting of carbon and hydrogen. Sometimes they can have something else in there. A hydrocarbon derivative, for example, might have oxygen in it. And it can also burn. So if it burns an oxygen and it's a hydrocarbon, it will always produce the same two products, carbon dioxide and water, plus lots of energy. Note that the reactant for all combustion reactions is oxygen, and you need some fuel, which for a hydrocarbon combustion reaction might be something that looks like this, which is the formula for methane. So all combustion reactions that occur with a hydrocarbon, again, produce carbon dioxide and water and lots of energy.